Okay, Chapter 5, Section 1. We are going to be working with trig identities, and we will probably be working on this until Christmas break. So we're going to take our time going through it. It is something that you will see here and there. It's mainly just solving equations, but they're going to look a little bit differently because we're going to be using the trig functions. And the trig identities we kind of talked about in Chapter 1. So first off, there is a recap of those trig identities in Chapter 5, and they are in the green box on page 197. And if you need a note card when you're in class, let me know, but those should be on a note card for you to have anytime you need them. So on the front of your first card, you can put your reciprocal and quotient identities. On the back, put the Pythagorean identities, but I want you to leave a space between each identity. Remember, with the Pythagorean identities, there are 3 of them, but leave 2 spaces between each one because we can rewrite them, and I want you guys to have them all. And then on card 2 on the front, you can just put the even and odd identities, and then we will add to card 2 as we move on through this chapter. So, example 1 is we are given tangent theta equals -5/3. Theta is in quadrant 2. So unit circle is going to come back around. Remember, in the unit circle in quadrant 2, sine is positive, cosine is negative. That will mean tangent is negative, and that will also mean cotangent and secant are negative. So sine and cosecant are positive. Everything else is negative in quadrant 2. So we want to find secant theta given that tangent theta is -5/3. And we're going to do this using an identity. So since we have tangent and we want to find secant, there is an identity that has tangent and secant in it, and it is a Pythagorean identity. So we are going to use tangent squared theta plus 1 equals secant squared theta. So that is the identity we are going to use with this. With that, we know what tangent is, so we're going to plug that in. Since tangent is squared, we're going to square that value. So we have -5/3 squared. And we're going to add 1 to that, and that's going to equal secant squared theta. So remember, when you square a fraction, square the numerator, square the denominator. So -5 squared is 25. 3 squared is 9. Still adding 1. And that's going to equal secant squared theta. Remember, in order to add these, 1 has to become 9/9. They have to have that same denominator. So we have 25/9 plus 9/9. 25 plus 9 is 34/9. And that's going to equal secant squared theta. So now, in order to get secant, which is what we originally wanted, we have to take the square root. When you take the square root, you take the square root of the numerator and you take the square root of the denominator. So we will have the square root of 34. Also remember, every time you take the square root, you have a chance of it being positive or negative. So we have plus or minus the square root of 34/3. And that's going to equal secant theta. Since we are in quadrant 2, this is why it told us secant is negative in quadrant 2. So my final answer, secant theta, is going to equal negative square root of 34 over 3. And that is your final answer. So now we're still in example 1, and we're going to use the information that we have. We know from the problem that tangent theta equals -5/3. We also know from just solving in part A that secant theta equals -√34 over 3. I now want to find sine theta. So I need something really, let's focus on what we have. I want something really that will connect tangent and sine. Okay? So we're going to use for this one, and it's going to also incorporate that secant, but it's going to be in a different way, and you will see. So we want to connect tangent and sine. So we want to use the quotient identity. Tangent theta equals sine theta over cosine theta. So we're solving for sine. So let's go ahead and manipulate this equation. We're going to multiply both sides by cosine. Cosines are going to cancel here. So what we actually are going to use is cosine theta times tangent theta is going to equal sine theta. So now you're probably thinking, Miss McAllister, we don't know what cosine theta is. And I'm going to say that you're right. We don't know what cosine theta is. However, secant is the reciprocal of cosine. So we are going to replace cosine with 1 over secant theta. We're still multiplying that by tangent theta. And then that's going to equal sine theta. So now we have our identity the way we need it to be. So plugging in, we're going to say 1 over -√34 over 3. And that's going to be multiplied by tangent theta, which is -5/3. And then that will equal sine theta. So let's take care of this mess right here. Remember, when you have a fraction divided by a fraction, you're just going to keep your top, flip your bottom fraction, and change your sign. Or you can say, well, secant is the reciprocal of cosine, so all I really have to do is flip that. So that means that 1 divided by -√34 over 3 is just -3 over the square root of 34. And I know we have a radical in the denominator, but we will take care of that once we multiply it by this -5/3. So with this, my 3's are going to cancel. I'm going to move up here. I will have negative times a negative is just a positive. So we will have 5 over the square root of 34 equaling sine theta. Cannot have that square root in the denominator. So we got to rationalize. Multiplying by the square root of 34. We have 5 square roots of 34 over 34 equaling sine theta. Now remember, we were in quadrant 2. Sine is positive in quadrant 2, so that is your final answer. Part C, we want to find the cotangent of negative theta. This right here probably looks a little weird to you. probably look at your identities and you say, I don't have anything that has that negative theta in it. I believe in chapter 1, we did talk about when the negative is inside the parentheses, we can just pull that out. So, we know what tangent is, we know what secant is, and we know what sine is. We can do this very easily. There is tangent and cotangent are reciprocals. So, for this one, we want to use that cotangent negative theta equals 1 over tangent of negative theta. Remember that cotangent just equals 1 over tangent. Since the negative theta is there, it's going to be here. Since it's in the parentheses, we can pull that out. So the cotangent of negative theta is going to equal 1 over negative tangent theta. Now, because I knew what tangent theta was, I did not know what tangent of negative theta was. Now I have what I can plug in for. So cotangent of negative theta is going to equal 1 over negative 5/3, because tangent is negative 5/3. So a negative and a negative gives me a positive. So 1 over 5/3, and now we can just flip that and make it 3/5. So cotangent of negative theta equals 3/5. Example 2. We want to write cosine x, and your book is going to interchange between theta and x. And I know when we did graphing, you guys got a little confused. Theta and x are interchangeable. It's a variable. Okay, it means the same thing. It's representing the angle. So we want to write cosine x in terms of tangent x. So you gotta think to yourself, how is cosine and tangent related? We have that identity that we used back in example 1, part A. So we know that tangent squared x plus 1 equals secant squared x. Again, we don't want secant, we want cosine. So we are going to rewrite this in terms of reciprocals. So since we need secant to be cosine, we have to write that as 1 over secant squared x. And what we do to one side, we do to the other. We then can say 1 over secant squared x is going to equal cosine squared x. I keep wanting to write theta. And this is still going to say the same because we don't have an actual reciprocal for that. So since secant squared x, we have to make it in reciprocal form before we can change it. Moved it to 1 over secant squared x. Since we did that to this side, we have to do that to this side. So we put everything over under 1. 1 over secant squared x is cosine squared x. This is going to stay the same. I need to write cosine in terms of tangent. So since this is squared, I need to take the square root, and we will have plus or minus the square root of 1 over tangent squared x plus 1, and that's going to equal cosine x. However, Square root's on the bottom, technically. So we technically have this plus or minus the square root of 1 over the square root of tangent squared x plus 1. Since that square root's on the bottom, we need to rationalize, so we need to multiply by tangent squared x plus 1 over tangent squared x plus 1, the square root of that. This is going to become the same. This, since we're just multiplying by 1, we can say plus or minus the square root of 1 plus tangent squared x, or tangent squared x plus 1, and that's all going to be over tangent squared x plus 1. And that's going to equal cosine x. So that is your final answer right there. Last but not least, we have example 3. We want to write 1 plus cotangent squared theta over 1 minus cosecant squared theta in terms of sine and cosine, and then simplify the expression. So we want to turn these identities into terms of sine and cosine. And when we go to simplify identities or prove identities, this is setting us up for that, because it is always the easiest thing to do to switch them to in terms of sine and cosine. Makes things a lot easier. It cancels things out a lot easier. So putting things in sine and cosine is the key to identities. So 1 plus cotangent squared theta. We have the identity. We want to go ahead and switch that to sines and cosines. So 1 plus cotangent squared theta over 1 minus cosecant squared theta. We're going to change cotangent to terms of sine and cosine. We're going to change secant. So my first move, I'll have 1 plus cotangent is technically cosine over sine. Cosecant is 1 over sine. In order for us to add these in the numerator and to add these in the denominator, we have to multiply, because they do not have common denominators, by sine squared theta. We're going to multiply this whole thing by sine squared theta. When we do that, we end up, so we're going to come this way. Sine squared theta plus cosine squared theta all over sine squared theta. And that's going to be divided by 1 sine squared theta minus 1 over sine squared theta. Since these both have the same thing, again, you're going to keep your top fraction, flip your bottom. So we will have sine squared theta plus cosine squared theta over sine squared theta. We're going to multiply that. We're going to flip that bottom. Sine squared theta over sine squared theta minus 1. These are going to cancel. We will end up with sine squared theta plus cosine squared theta all over sine squared theta minus 1. We then can simplify. This right here is a Pythagorean identity. It can be changed. Sine squared theta plus cosine squared theta is 1, so it can be changed to 1. And then sine squared theta minus cosine squared theta is another identity, and it could be changed to negative cosine squared theta. So we are just plugging in what they equal. Like if you had x plus y equals 4, well, anywhere you see x plus y, you can substitute 4 in for that. So we know that sine squared theta plus cosine squared theta is 1. So we can just drop that in its place. We know that sine squared theta minus 1 is negative cosine squared theta. We can just drop that in its place. We're simplifying. 1 over cosine is secant. So your final answer, since that's negative, is negative secant squared theta. So put things in terms of sine and cosine, and then simplify. Your homework is posted on the agenda. Be sure to check the agenda in the December folder under week 13. That agenda tells you everything for the week. It also tells you that you have a quiz on Friday. So I would be sure to plan accordingly so that you are available for that quiz.